Hello everyone. In this lesson we're going to do a quick overview of the idle text editor and interpreter in Python. We're going to take a look at expressions, variable types in Python, and string concatenation. And at the very end we'll do a little tricky exercise that will make you think about how Python handles expressions and interprets them. So we've already installed Python and installed Visual Studio Code and a couple other items, but in this case we're just going to use the built-in Python idle program that's installed with the Python package. So go ahead and hit the Windows key and start typing idle, I-D-L-E, and you will see a idle app that pops up. In this case we installed Python 3.8, and we'll go ahead and click it. I've already adjusted the font size up a little bit so it's easier to see in the video. So in Python, the first thing to think about is the concept of expressions. So expressions, at the very bare minimum, contain values and then also can contain an operator. So for instance, let's say we have a value of 2. And in idle, we can type in a line of Python code and execute it. We'll talk about building Python files in a later lesson. In this case, we're just going to use the idle shell. So go ahead and type in 2 and hit enter. And what you've told Python is, hey, I have a value. It's an expression, doesn't necessarily need an operator. Please interpret it. You can do the same thing using a negative sign if you want a negative value. So we could type in -2. That is a valid expression. Go ahead and hit enter. Python then interprets what I've typed to -2. Now we talked about an expression being a set of values and a set of operators. So let's go back to basic math. Let's try 2 plus 2. 2 plus 2 equals 4. So what have we done? We've told Python, okay, I have a set of values, 2 and 2. Stick a plus sign in there. Python says, oh, looks like you're doing addition. When we hit enter, we're passing that expression off to Python and it reduces to 4. We also have subtraction. 2 minus 2 is 0. Multiplication, 2 times 2 with an asterisk is 4. Division with a forward slash, 2 divided by 2 is 1. And modulo arithmetic, 2 mod 2 is 0. And mod in Python, just like C# and C++, can be represented by a percentage sign. So very simple. We have 2 values, an operator in between them. And like other programming languages, Python looks in an order of precedence. So we can use parentheses in our expressions, and Python, just like other languages, follows the same order of precedence. So if we have 2 times 2 minus 2, Python will evaluate this to 0. We could move the parentheses around and change the order of operations. So parenthesis 2 times 2 minus 2 will yield 2. So an expression can also contain parentheses that change the order of operations. Given your backgrounds in programming, in your prior experience in other courses, this should be nothing new, and you should be able to use expressions in Python just like you would any other language. So let's talk variables. So in Python, we have variables just like every other language, and we're going to talk about 2 features of Python. It's both strongly typed and dynamically typed. So what does that mean? Let's talk about dynamically typed first. In dynamic typing, you don't necessarily need to specify the variable type when declaring the variable. Python will look at the value and automatically type the variable and create the variable in memory based on the value you've passed it in your expression. So for instance, we're going to create an expression spam. Spam is my new variable, equals 3. So what have I done here? I've created a new variable called spam, and I've set it equal to 3. So variables are initialized when a value is set to them. And how are they initialized? What's the type that's selected? Well, Python looks and says, I've put a 3. I haven't put quotes around it. This looks to be an integer, so I'm going to make the variable spam an integer. Python has 4 main primitive types: integers, floats, booleans, and strings. It also has many other types, but those are the core types within Python's primitive variables. It tries its best when it's looking at variables to interpret and allocate memory and the variable type properly. But again, you don't need to specify the variable type. It's much like the var type in C#. You can use int, you can use string, but if you specify var, you're relying on the interpreter to create and type the variable for you. Now we can also, well, let me back up. Let me show you the output of spam. So let's go print spam, and you'll be using print. It's very similar again to C#, C++, other languages. You throw in the variable within print, and we can print the value to the screen. It automatically does the type conversion for you, and we'll talk about type conversion towards the end of this lecture, because it can get a little confusing sometimes based on how you're doing explicit type conversion. So this is an example of an integer variable. We can have can equals Arizona T, and we can print that to the screen, and we get Arizona T. Now again, we have a value of Arizona T, variable name can. Python has said, oh, this looks like a string. Let's go ahead and turn that variable type into a string. So again, this goes with dynamic typing. Python is able to look at the initialization value and automatically set the variable type to it. So let's talk about strings. Strings, just like numbers, can be concatenated or modified using operators, similar to other languages as well. So let's go back, stop using variables for a second. We talked about Arizona T, so let's use Arizona T. So we'll go Arizona. We'll create a one string there called Arizona, add a plus sign, T, and the output will be Arizona T, no space. So again, you can concatenate or add 2 strings together. We can also multiply strings. So let's say you got a good deal on Arizona T, 3 for $2. Go ahead and hit enter. And we get it 3 times. So you can multiply strings, and all that does is repeat the string over and over. So it's a neat little trick, but this is really to show you that operators can be used on more variable types than just integers. You have to be aware of what operators your specific variable type you're working with supports. But again, another example that it's not just restricted to numbers. So we've talked about dynamic typing. Let's talk about strong typing. So this is where we get into a bit of a brain teaser for the end of this lesson. But with strong typing, you need to be aware of the specific types of the variables that you're using. So let's create 2 values. Okay, we'll create 2 values. Let's call it Earth. And we'll set Earth equal to 2. And Moon we'll set equal to a string value of 3. All right, so we have 2 variables. One is a variable Earth. It's a integer value of 2. And we have Moon. It's a string value of 3. So in the dynamic typing concept of Python, Python has allocated memory for an integer called Earth, automatically in memory with a value of 2, and it's initialized it to that value, and then Moon as a string and initialized its string value to a string of 3. Now if we go and try to print these together, let's create Earth, Moon, and we'll call it I know Moon's not a planet, so planets equal Earth plus Moon. This is a programming class, not an astronomy class, so just don't show this video to your favorite astronomy professor. If we try to do planets equals Earth plus Moon, we get an error. Now, make yourself familiar with how Python displays errors. We're all going to run into a lot of errors as we go through this course, so it's important to understand the feedback Python's giving you. So in here it's saying, okay, file, PyShell 17. This isn't a Python file itself or a Py file, so the line number really isn't helpful, but we know it was the previous line because we just typed it in. So in the previous line, it gives us a type error, unsupported operand types for concatenating int and string, or adding int and string. Now what does this mean? This goes into Python being strongly typed. You cannot dynamically add an integer and a string together, or a string and an integer together. You need to explicitly convert these types in order to merge them together, and sometimes it can yield different results. So this is where we get a trick. So in here, we create a variable planets, and we're trying to use the plus sign to put Earth and Moon together. The question is, what does that plus sign mean? Well, it means two different things. If both Earth and Moon are integers, it means add them together. If Earth and Moon are strings, it means join them together. So it's slightly different, and Python doesn't know what to do with it. It doesn't know your intention in typing it up. So we have to do one of two things. Either Earth needs to be converted to a string so we can concatenate Earth and Moon, or Moon needs to be converted to an integer so we can add Earth and Moon together. So let's try the two different approaches. So let's say planets equals, let's convert Earth to a string first. So we're going to concatenate Earth and Moon. So we'll do an explicit type conversion. It's str in Python, str, Earth plus Moon. Now we don't get an error, so we can print planets, and we get the string of 23. Now, what if we do it the other way? What if we convert Moon to an integer to match Earth? So planets equals Earth plus int. So int is your explicit conversion function, and we're going to drop Moon in there, so the function output's going to be an integer. Now let's print planets. 5. So it's interesting. In the first case, we're quote-unquote adding, so we're concatenating 2 and 3 to get 23. In the first case, it's a string representation. In the second, we are adding two integers together, 2 and 3, to get 5. So this is a real interesting example of why you have to be extremely careful to properly type your variables and to explicitly cast your variables as the types in the ways you intend. Because again, if we were to convert these two values to then integers, they mean completely different things. So two things to consider with variables in Python. One, dynamic typing. You don't have to bother with adding a type in front of your variable declaration. And then strong typing. You need to ensure that when you're operating on more than one variable, so using an operator, that those variables are compatible and they've been converted to the ultimate variable type you want to be output in the expression. So again, in this example, we had a string and an int. If you want it to be treated as a string for the one variable, you have to do it one way. If you want another variable to be treated as an int, you need to do it the other way, but the results are wildly different. So be careful when dealing with strong typing situations.